Okay, so this is the second of two videos, and I'm going to add a little more complex vector. So this one is going to be in this direction here, and it's going to have an angle here. This is going to be 7.6, and this is going to be 51 degrees. And it's going to be added to another vector, which is going to be in this quadrant here. This is 22 degrees, and this is 18, the size 18. Okay? So I'm going to do exactly the same thing that I did before, if I can find where that thing went. Okay? I'm going to do exactly the same thing that I did before. Here it is. Let's just grab this down. I'm going to do the horizontal and vertical components of both, and I'm going to do it just in this bit here. Don't forget about the positive and the negative. Okay? That's a key thing here. So I've got horizontal and vertical of the 7.6. Oh, shouldn't have put it there. Shouldn't have put it there. Let me just rub that out before it makes a mess. Okay, so then I'm going to put this down here, and this is going to be the 7.6 vector. This is going to be the 18 vector, and then this is going to be the sum of them. Okay, so the 7.6 horizontal is negative. It's pointing in that direction. So immediately we just put a minus in front, and I'm stretching it to get it horizontal, so it's 7.6 sine 51. Vertically is positive, it's going upwards. 7.6 cos 51. Remember what I told you? These must both be different. Be careful of the signs. Okay, this one here, the 18 one, is negative horizontally and negative vertically because it's in this quadrant. So minus horizontal 18 sine 22, because I'm stretching it, and minus 18 cos 22, because, okay, that's the vertical component. So I just calculate these quickly. 7.6 times sine 51 equals minus 5.90631. 7.6 cos 51 equals 7.6 times cos 51 equals 4.78283. 18 times sine 22 equals minus 6.7429, and minus, 18 times cosine 22. So minus 16.6893. I'm just going to add them because I've got that minus 16, so I'm going to do 4.78283. Oh, the divide, idiot. 4.78283 minus 16.6893 equals minus 11.906, and this one is minus 5.90631 minus 6.7429 equals, syntax error, idiot. So minus 1 times 5.90631 minus 6.7429, which is minus 12.6492. All right, so this is horizontal, don't forget, and this is vertical. So in fact, that's silly to do that. So in fact, if we look at this quadrant here, this vector has minus in the horizontal of 12.6492 and minus 11.906. Is that right? 906 in the, okay. So this is going to be the resolved vector. Imagine just pushing this over there and doing this. I'm going to call this angle beta. So I'm going to use Pythagoras, square that, plus 11.906 squared equals square root the answer, and the size of this, the magnitude of this thing here, is 17.4 newtons. Oh, no, not newtons. We got 17.4 to three significant figures. Tan beta is equal to 11.906 over 12.6492. Notice they're so similar, it's probably going to be about 45 degrees. 11.906. In fact, it's going to be just less than 45 degrees, 12.6492. Shift tan, answer equals 43.3 degrees, correct to 3 significant figures. I hope this has given you an idea. The key thing when you get vectors that are in these funny directions is just to make sure you keep the senses right. If you can keep the senses right, everything will work perfectly.